Today's video will describe how the vector is able to grow. Hello, I'm James Helfrich. The fundamental difference between the vector and the built-in array or the standard template library array is that a vector can grow, or more specifically, change size. And this is done primarily through the reserve method. This video will explain how the reserve method works, as well as how it relates to push back, push front, and the other resizing mechanisms. Consider the class diagram for the vector. There are a surprising number of methods that relate directly to resizing. For an example, we have the assignment operator, which can grow the vector to accommodate the size of the right-hand side. We have reserve, which will change the capacity. We have resize, which will change the number of elements. We have shrink to fit, which will also change the capacity. We have push back and push front. We have pop back and pop front, as well as insert and remove. So a large number of methods for the vector relate to changing the size. There are two attributes related to the size and the capacity. The first one is number of elements, and this is how many elements that are currently in the vector. And the second is num capacity, the current capacity of the vector, and this is how many elements can fit before the vector needs to be grown. Now, I can always query the vector to see how many elements are currently in it with size, and I can also query the vector to see what the current capacity is with capacity. Now, if I want to change the size of the vector directly, then I can say resize and to n elements. Now, let's say there used to be 5 and I say resize 10. That means it's going to add 5 elements to a total of 10. Now, resize will also decrease the number of elements to n. Now, of course, if I want to change the capacity, I'm not going to say recapacity, which you would think would kind of make sense. Instead, I say reserve. And this will only grow the vector to a certain number of elements. So let's take a look at how this works. So first of all, I'm going to have a vector, and I'm going to say v. So my vector is empty from the client's perspective, but internally I'm going to have my three member variables. V data is the null pointer, num elements is 0, num capacity is 0. Now if I say resize 3 from the client's perspective, I'm going to have three elements, z, 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 because I'm going to initialize it to the value z. So internally, I'm going to first allocate three elements. When I allocate them, then I'm not going to call the constructor on them. Notice how num elements is 0 and num capacity is 3. And then I'm going to go through and fill each element with z by calling the non-default constructor with that second resize parameter as the input parameter. So it'll be z, z, z. Now num elements equals 3. Now, if I say reserve 5, then I'm going to say the size will remain the same as 3, but I'm going to have two uninitialized elements on the end. And from the client's perspective, I represent this with two transparent boxes. Now, internally, I have to do a little bit of dance. The first thing you have to do is realize that my current capacity is less than 5, so I have to allocate a new block of 5 elements. When I allocate them, then I'm not actually going to call the constructor. And then I'm going to move the elements from the old buffer into the new buffer one at a time. And then once they're all moved over, then I can free them out. Now, when this is finished, notice how my num elements remains 3, but now my num capacity is 5. I cannot grow a buffer. I can only reallocate a new buffer. And this happens with std move, which is how we move the elements over. Now, when I say push back A, from the client's perspective, I'm just going to take one of those transparent blocks and initialize it to A. Now, internally, when I say pushback, I'm going to first see if the new size is going to be less than or equal to the capacity. And since my new size will be 4 and my capacity is 5, I can simply add it on without changing the buffer at all. When I say resize 2, I'm going to get rid of 2 of the extra elements because my current size is 4. So from the client's perspective, I'll have 2 fill blocks and 3 transparent blocks. Now, when I do the same thing internally, I don't actually reduce the capacity. In other words, I only call the destructor on those last 2 elements. And now my num elements is 2 and my num capacity is 5. Okay, let's see how this works from the pseudocode. First of all, we're going to take a look at reserve. Now, the reserve is going to have my new capacity as an input parameter. Now, if my new capacity is less than or equal to current capacity, then I do nothing. In other words, I only grow my size and my capacity. I don't shrink it with reserve. Now, what I need to do is allocate a new block of data. Now, I'm going to use the allocator here because the allocator allows me to separate 2 separate operations. The first is to request memory from the operating system, and the second is to call the constructor on those slots of memory. I want to do those separately because I want the excess capacity to not have the constructor called on it. So alloc.allocate will allocate a buffer of that size, but will not call the constructor. And then I'm going to move all the elements over from the old buffer from data into my new buffer one at a time. Move it over, move it over, move it over. And now I'm going to call the destructor on the old elements. And then finally, I'm going to deallocate the old buffer. And now I'll update my data for my new data and my num capacity with my new capacity. And this is how I do things in a two-step process. Now let's see how this works with pushback. With pushback, I'm going to push back a t, and I'm going to first say, hey, look, if my current capacity is 0, then I want to reserve exactly one slot. And this will allocate one slot, and then I will initialize it. If my size equals capacity, in other words, I'm full, I want to double the capacity. And the reason why I want to double the capacity is because I want the cost of pushback to be log n on average. Let's say that instead I increase the capacity by 1, then every time I push back on a full buffer, I'll have to reallocate, 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 and then it's going to be on average O sub n. And if I do it n times, it'd be n squared. Here, if I double the capacity every time, I will do a total of log n calls to reserve. In other words, the total cost would be n log n, where n is the number of times I call pushback. All right, after these 2 lines of code, now I can be sure that my capacity is the correct size, and I can just say array equals num elements plus plus gets the value t. You can learn more about reserve and pushback in the implementation section of the vector chapter of the C++ data structures textbook.